we're just solving for x on this thing, and so we'll do it's the same problem. We'll do it both ways, and let's start by getting rid of the denominators. Now, in order to get rid of the denominators, we have to know what they all are, and a lot of people, we miss the x right there, but it does have a denominator. It's 1 right there. Okay, so we got denominators of 2, 2, 1, and 4. We need them all to be the same. Now, the good news on this one is that the denominator of 4 and 2, they're both related. And you could say 1, but 1's related to everything because it's the identity property, right? But for 2 here and 4, 4 is just it's 2 times 2, right? So changing all these fractions into 4s isn't going to be hard. It's just remember, if you do it to the bottom, which is what we're doing, the denominator, you got to do it to the top as well. Not 4, but 2, right? So like this one, that 3 over 2 times x is going to become 6 over 4 times x. And then the 1/2, same thing, right? We're still multiplying by 2 to make that 2 over 4. Again, and this is a crucial idea to notice on this, with this method, that we haven't changed the values, we've just changed the way that they've looked, that's it. And then this equals, so 1, of course, you'd have to multiply 1 by 4. So multiply x by 4 as well to make this 4x over 4, which again has a total value of just x, really. And then we just keep that 1/4 the same like this. So we've accomplished getting all the denominators the same, which is, kind of what we wanted on this one. It's just, so, yeah, we have the denominators, and, yeah, it's, well, why do we get the denominators the same? It's so that we actually don't have to look at them at all. So it's 6x minus 2 now equals 4x plus 1. Now, the reason why we can get rid of the denominators is because we're dealing all in the same size pieces, in fourths in this case. So now that we're dealing all in the same size pieces, whether you add, subtract, multiply, or divide any of these, it's never going to change an outcome. So once you get the sizes of the pieces, which is the denominator, to be the same, then everything after that is just, well, it would just straight operations. Okay, so at this point we just look and we say, well, which side do we want the x's on? So we'll keep them there, and we'll say, we'll put the numbers here on the right. So we do a little bit of analysis at this point, right? The 6x is going to stay on that side because it has an x, it's a term with an x. But that -2, no, we don't want that there. It should be on the number side of things. So we're going to add it to itself to zero that out. And just to save us a little bit of time on this, and maybe space, we could say the 4x also is on the wrong side, so we can zero that out as well. So now we got 6x minus 4x, which is 2x. And this is going to equal 1 plus 2, which is 3. And then finally, just to finish this off, we'll divide both sides by 2 to make the coefficient of x a 1. So x now equals, we'll just keep it as a fraction, 3/2, 1.5, it's not going to matter. All right, just straight working with the fractions on this, and, this is a lot easier when you have a calculator like this one, or the TI-30 one that works with fractions. It's got the fraction button, which makes it very convenient. But there's not that portion of analyzing, well, what denominator do we need? So it's just, okay, we jump straight into principles of equality, where we say whatever we do to one side, we have to do to the other side. So again, we look at that -1/2, and it's on the wrong side, so we're going to have to zero that out. So let's say, add 1/2 to both sides to zero that out. And whether you do it in 2 steps or 1 is really up to you. But we get the 3/2 x equals x now, and then 1/4 plus 1/2. We can show the work down here. But again, I would recommend putting it into a calculator, and this is where that idea of getting the common denominators is really convenient, because then we don't have to worry about doing this kind of business, where we say, the 2, again, we got to have it to be common denominators before we can start adding and subtracting fractions. So this then becomes 1/4 plus 2/4, which combines into fourths, is 1 and 2 of them, is 3 of them. So this ends up being positive 3/4 there from that working green. And then that x is on the wrong side as well, so we'd say you got to get rid of that, zero it out. So subtract 1x there to zero that out. Still drop the 3/4. But now it's 3 halves minus 1, which is really 2 halves. And again, ones are nice to work with because it's just the same thing divided by itself. And this would combine in halves to be 1/2. Now that's half of an x. And then this final step here is, would say, well, divide this side by 1/2, because anything divided by itself is 1. But again, whatever you do to one side, you got to do it to the other side. So x equals, and again, if you're doing it by hand, you'd say, well, you don't actually divide fractions. You multiply them by reciprocating the fraction. Then 3 times 2, that's going to be 6, and 4 times 1 is 4. But this can be simplified to be 6/4. Both those are divisible by 2. So we get the same answer, right? On both of these. It's just which method you like. And even though I'm showing the work by hand on the right side, on the work on the right, for the most part, I would say, it's plugging it in the calculator is a lot easier that way.